a number of studies always taking place on board the International Space Station, tracking astronaut health in a variety of ways, whether it's different bodily systems or even how the astronauts are able to function while in that microgravity environment. And we're lucky to be joined today by one of the principal investigators of a study that's taking a look kind of at a bit of the nuts and bolts of how the astronauts are able to function while they're in that microgravity for a long period of time. And it's a study called Cognition. And I'm joined today by the principal investigator, Dr. Mathias Basner, from the University of Pennsylvania School of Medicine. So first off, Dr. Basner, thank you so much for joining me today. And I'd like to jump right in. So what exactly about the space environment could cause, changes in the astronaut's cognitive ability?
Well, good morning, first of all, and it's a pleasure to be on your program. First of all, there's, of course, psychological factors related to living in an isolated, confined, and extreme environment that could affect cognitive performance. But there's also a lot of environmental stressors, some of them unique to the spaceflight environment, like microgravity, or think of radiation during exploration type missions that can affect cognitive performance. And another factor that we know of is like ISS, 6-month ISS missions are characterized by high workload periods and also chronic sleep restriction. Of course, these factors may also affect cognitive performance.
Okay, so we know some of the, external factors that can cause these. What are some of the actual issues, the cognitive issues that these could cause? What are we worried about?
Well, obviously, cognitive performance has very many facets, and all of them are important for mission success in one way or another. 3 examples are, for example, attention, memory, and reasoning that are very important. What our test battery looks at also is spatial orientation, risk decision making, and emotional processing, which we believe are really essential for mission success. So one example is the emotional processing. So the question is, if you're going to Mars and flying back, are you still able to read your fellow astronauts' faces? If somebody is angry, are you still able to detect that? And this is what we're looking at, for example.
So a lot of the underlying things that can have a huge effect just on, the day-to-day life of these astronauts on board. You had mentioned fatigue and sleep. Obviously, I know when I don't get a good night's sleep, that can ruin my whole day. Is that something you guys have kind of looked into, how to better manage the sleep and fatigue factor of cognitive ability?
Definitely, yes. And obviously, fatigue resulting from sleep loss is only one factor that can affect cognitive performance. NASA has actually put great effort in the past, both in terms of basic research and in terms of applied research, to mitigate the risk associated with chronic sleep loss. I guess the best example is the lighting system. The current fluorescent lighting system is in the process of being replaced with state-of-the-art LED lighting, where the intensity and spectral composition of the light can actually be varied systematically. So, for example, in the morning, you could expose the crew to alerting blue enriched light, while in the evening, you give them red light, which is promoting the secretion of melatonin, which helps them go to sleep more easily. So these are just a few examples.
Pretty cool thing, just, playing with the lighting. These men and women don't get, normal sunrise, sunset like we do. So you don't always think about it, how big of an effect that can have.
Yeah, they have it every 90 minutes, pretty much, dusk and dawn. So yeah.
Okay, so what are some of the things how are you guys testing this? What are some of the actual actions you're doing to try and test this cognitive ability?
Yeah, so our software is installed on one of the HRFPCs in the Columbus module. Cognition itself is a battery of 10 cognitive tests specifically designed for the astronaut population, because we know astronauts are high performers, they're highly motivated. So just taking a standard cognitive test may not work for this population. It takes less than 20 minutes to administer. That time is gold on the space station. It's very rare. The battery covers a broad range of cognitive domains, and we know which brain regions are recruited by each of the individual tests, which is important so we can make indirect inferences. If we see a decrement in one test, we may know what brain region is affected, which is important because we don't have neuroimaging capability on the station right now. What the astronauts currently do, they take the full battery 4 times pre-flight, 11 times in-flight with 2 to 3 week intervals during 6-month missions. and 3 times post-flight. And the data are then compared within each individual astronaut, but we also generated normative data on the ground in an astronaut population that is not affected by any of the spaceflight stressors. Cognition is also part of the 12-month mission, and it's also part of the twin study that NASA is performing right now.
Okay, so after we've collected all the data and we're able to look at it, how is this going to be able to help? What will your test be able to do to help improve on the cognitive ability of astronauts, not only on space station missions, but say astronauts like you had mentioned before on a trip to Mars or something? How is this going to help?
Yeah, so right now, Cognition is really a research tool. And what we want to do, we want to find out how individual spaceflight stressors affect cognitive performance with the goal to mitigate these risks. So what are the individual stressors? How do they affect performance? Is there something we can do about it? Obviously, in the long run, what we would like to see is to really transition Cognition into operations so that we can use this tool to monitor astronaut cognitive performance, very much like NASA is doing with WinSCAT right now. What the software already does is each astronaut gets immediate feedback. So the software will provide a standardized score after each test, and it will also show historic data, so the astronaut can see how he or she has performed on the test in the past and how the current test bout compares to that data.
Very cool. And one thing we're always interested in finding out, so much of what we do on board the station, having some direct benefits to, those of us back down here on Earth. How could this cognition study potentially help, just regular people back down here on the surface?
Well, as I mentioned earlier, we specifically designed this for astronauts, and astronauts are a high-performing populations, but there are other high-performing populations on the ground. Think, for example, of medical doctors, where we could apply this test battery in these populations. Cognition is already embedded in 4 Antarctic stations, which NASA actually uses as a space analog environments. And obviously, these environments are also harsh, with threat to life conditions, with confinement, isolation, and also with the strange lighting conditions that we have on the space station or on a trip to Mars. So, in the end, we can also help these populations to monitor them and to find out which factors are affecting cognitive performance in these populations.